Alright, so in this video we'll be looking at calculating oxidation numbers. And so this is just something that you're going to have to memorize in terms of the rules, as it is necessary in order to do a number of different problems when it comes to redox, your oxidation reduction, type problems. But anyway, so oxidation numbers themselves are kind of like a bookkeeping system, right, for your electrons. So we can keep track of the electron transfer, right, in our redox reactions. And so it doesn't always match the actual charge, especially for your covalent molecules, but it does show you how the electrons are distributed, so where they are going when these redox reactions are taking place. And so like I just mentioned earlier, there are certain rules that you have to memorize, and let's just get right into those rules. Number one, you should keep in mind that elements in their pure form are going to have an oxidation number of 0, right? And that's pretty straightforward, right? If we just have elemental oxygen, that is O2, elemental oxygen in its pure form as is going to have an oxidation number of 0. Elemental fluorine, that's going to be 0. Hydrogen, that's going to be 0. Magnesium, that's going to be 0. Anything in its pure form as would occur as it is, iron, right? Solid iron in its pure form, pure iron, is going to have an oxidation number of 0. So that's, again, pretty straightforward, but just remember that elements in their pure form have an oxidation number of 0. And that brings us to the second rule, another one that is pretty straightforward, and that is our monoatomic ions, right? Our ions are going to have an oxidation number that is equal to their charge. So if we have a sodium ion, that's going to have a +1 oxidation number. A chloride ion is going to have a -1. A magnesium ion, that's going to be +2, right? And so on and so forth. So when we're trying to find the oxidation number of an ion, it's simply going to be equal to the charge that that ion has. Okay, so far, so good. Now moving on to the third rule. This is going to bring us to oxygen, right? Oxygen, it gets a bit trickier in that is not just one rule. Well, let's just start here. Oxygen, when it's in a compound, remember we already talked about elements in their pure form. If it is just oxygen alone, well, that's going to have an oxidation number of 0. But let's say we have oxygen that's incorporated in some compound. In that case, oxygen is going to have an oxidation number of -2. But there is an exception, right? It's except when we're looking at peroxides and when we're looking at oxygen that is bonded to fluorine. If oxygen is bonded to a fluorine, or the oxygen is part of a peroxide, in that case it's going to have, right, well, in these cases it's going to have an oxidation number of -1, of -1. And so if we're looking at oxygen just regularly in a compound, it's -2, whereas when it's a peroxide or fluorine, it is -1. Moving on then to hydrogen. Hydrogen also is going to have an exception. Generally, hydrogen is going to have an oxidation number of +1. Again, when it's in a compound, not in its pure form, but when it's incorporated in some compound, it's going to be +1, except when we're looking at metal hydrides, right? Metal hydrides. Let's actually clear some space over here and say that, well, with peroxides and with our, so let's say that we're going to have a -1 with our peroxides and with fluorine. And hydrogen, except in metal hydrides, when it's not a metal hydride, it's going to be +1, but when it is a metal hydride, you're going to have an oxidation number of -1. So what is a metal hydride? Well, when we have our hydrogen bonded to a metal, that is going to be a metal hydride. So when we have hydrogen bonded to nonmetals, it will be having an oxidation number of +1, and with metals, right, that is going to be -1. And that comes down just to the electronegativity of hydrogen, right? Hydrogen is generally more electronegative than most metals, and so when it's bonded to those metals, its oxidation number will be -1. Whereas most nonmetals are more electronegative than hydrogen is. And so because of that, your hydrogen is going to have a +1 oxidation number. So the next rule to keep in mind, number 5, right, is fluorine. We're looking at fluorine, again, not in its pure form, not its elements in pure form, but when fluorine is incorporated in a compound, it is always going to have an oxidation number of -1. There are no exceptions to this rule, so it's just, it's pretty straightforward. When you look at a fluorine in a compound, the oxidation number is going to be -1. And the next thing to keep in mind is well, the fact that your group 1 metals have an oxidation number of +1 in your compounds. I'm just going to abbreviate this group 2. Your group 2 metals are going to have a +2 in compounds, right? Group 1 metals have a +1 and group 2 metals have a +2. So just remember those, again, when in compounds. And aluminum has an oxidation number of +3. So this aluminum rule, again, it comes up less frequently in problems, but it is just keep it in mind in case it does come up. And finally, the last thing you should keep in mind is just the fact that the sum of the oxidation numbers in a neutral compound is 0, and in some sort of polyatomic ion is going to equal the charge of the total ion, right? So these are just the rules to keep in mind. I know it seems kind of like a lot, but some of these are pretty straightforward. Like the first two are pretty straightforward. Fluorine is always -1. Group 1 metals are +1. Group 2 metals are +2, right? A lot of these are pretty straightforward, and I promise that as you just do more problems, right, getting practice using these rules, it'll really just become second nature. They'll become ingrained in your memory. You don't really need to necessarily go out of your way to do this. If you just do a lot of problems, they will kind of just come to you more naturally. But in the beginning, it may be a bit hard to recall. But so in which case, just have these written down, or have a way to reference them when you're starting out. And then as you just do more problems, you will automatically start to remember them. Okay. So now speaking of problems, let's just get into some problems, right? To see exactly how this all comes together. Well, let's start off with H2SO4. Let's say that we have H2SO4, and we want to find the oxidation number. So what is the oxidation number of sulfur in H2SO4? How do we go about doing this? Well, this is kind of how these types of problems work. Looking at the rules that we went over earlier just now, right? Sulfur was not mentioned in any of those rules. I mean, sure, elements in their pure form, sulfur in its pure form, we know is 0, but here sulfur is incorporated in some compounds, incorporated in this H2SO4. So we don't have any rules from our rules list that we went over previously in order to figure out what sulfur is directly. But we do know the rules for hydrogen, we do know the rules for oxygen, and we do know the fact that by adding up the oxidation numbers of all the elements that make up this neutral compound, that has to be 0. Well, so using those known facts, we can figure out what sulfur is, right? Well, let's start off by looking at hydrogen, right? We know the rule for hydrogen. In this case, it's not a metal hydride. We don't see our hydrogen bonded to a metal, so we know it is going to have a +1 oxidation number. And the thing with oxidation numbers is you have to take into account how many of each element there is. So in this case, we're seeing that we have 2 hydrogens. So this is going to be +1 times 2, giving us +2. So our hydrogens in H2SO4 are going to contribute a +2 oxidation number, in total. And then looking at our oxygen, for which we also have, the rules for, we can remember that our oxygen here, 1, is not in a peroxide and it's not bonded to fluorine. So we are not looking at an exception case. We're looking at our normal rule that oxygen is going to have an oxidation number of -2. And well, we have 4 of these hydrogens, so multiplying by 4 is going to give us -8. So we have our oxygen contributing a total of -8 in terms of oxidation number. And let's just say, let's call our sulfur, or let our sulfur's oxidation number be represented by the variable x. Okay? So let's say, well, we know that the oxidation numbers of hydrogen, oxygen, and sulfur here has to add up to 0. So let's write that out algebraically. We know that x plus 2 plus -8 has to equal to 0. Well, that's just x plus 2 minus 8 equals 0, or x minus 6 equals 0, giving us x is equal to 6, or plus 6. And so this here is going to be our oxidation number for sulfur. Sulfur in this problem is going to have an oxidation number of plus 6. And so that's really how you work it out. We take what we know, and using the fact that this has to add up to 0, we can set up some sort of algebraic expression, solving for x, which in our case is going to be the oxidation number of sulfur. So it is somewhat like a puzzle, right? We take what we know to figure out what we don't know. So it isn't something that is too difficult, as long as you know your oxidation numbers and keep those straight. Next, let's look at Cr2O7 2 minus. So this is a polyatomic, right? It has a charge. And so what is going to be the oxidation number of chromium? Right? How do we figure this out? Let's just go about it the same way we did earlier. But keeping in mind that we're not looking at a neutral compound like before, we are looking at something that has a total charge of 2 minus, right? -2. And so that means that adding up the oxidation numbers of the elements that make up this compound, that's going to have to add up to -2. Let's just keep that in mind in case we, without forgetting that. So let's start off. Well, chromium, we don't have any rules for that in the rules list that we went over, but we do have the rules for oxygen. So in this case, oxygen, once again, is not bonded to a peroxide, is not, in a peroxide or bonded to fluorine. So we're looking at our normal oxidation number of -2. And we have 7 oxygens here, giving us -14. And what about our chromium? Our chromium can set that up to be x, like before, right? And setting up an algebraic expression, we can say that, well, in this case, unlike before, we only had 1 sulfur, so it was just x. But here we have 2 chromiums, so that is going to be 2x, right? Because just like with our oxygen, we had 7 of them, so we multiply the oxidation number of 1 oxygen by 7 in order to account for the total oxidation number that will be contributed by that one element. Similarly, we want to find chromium by itself, but we know that if we just add up chromium and oxygen, elementally just 1 of each, that's not going to be -2 here. We need to use that fact that we know that this compound's oxidation numbers have to add up to -2. That's what we're using here. So we know that we have to use 2x, 2 times that of chromium, and we can work backwards to find what the oxidation number of just chromium will be. Hopefully I didn't, over-explain that, and it did make some amount of sense. So 2x plus our -14 from our oxygen has to equal -2 in this case. So that is 2x minus 14 equals -2. 2x is equal to 12. And that gives us an answer of x is equal to +6. +6. That is what the oxidation number of 1 chromium is going to be in this problem. So, by coincidence, we just got our answer of +6 for our oxidation number once again. So again, common mistake is to forget the fact that we do have 2 chromiums. So when we are writing that algebraic expression, many students just write x like we did earlier, but you have to remember we have to account for the number of atoms of each element that make up that compound. So that in this case would be 2x. Now, looking at the next problem, let's say we have KMNO4, right? And what do we want to find? Well, let's find the oxidation number. Oops. The oxidation number of manganese. What is that going to be? Well, we don't have a rule for that. We have a rule for potassium, and we do have a rule for oxygen. What is the rule for potassium? Well, if you remember, potassium is a group 1 metal. We had a rule for that, right? So our potassium is going to follow the group 1 metals oxidation number rules, which is that it's going to have an oxidation number of +1. We see that we only have 1 potassium, so multiplying +1 by 1 gives you just +1. Then looking at our oxygen, again, in this case, our oxygen is not bonded to a metal. Excuse me, it's not in a peroxide or bonded to fluorine. And so because of that, we are going to be dealing with our standard oxidation number rule of oxygen having a -2 oxidation number. We have 4 oxygens, giving us -8. And we must find now the oxidation number of manganese, which we can call X. Right? Writing out our algebraic expression, we see X plus +1 plus -8. We'll see that KMNO4 is a neutral compound, so that's going to have to add up to 0. Well, this is just X plus 1 minus 8. Oops. 1 minus 8 equals 0. X minus 7 equals 0. And so our X is going to equal +7. +7 here is our oxidation number. So the oxidation number of manganese is going to be +7. And yeah, well, that should bring us to the end of this video. We looked through a couple of examples while we went over our oxidation number rules. We worked out a couple of examples. And really, all other examples that you may do in the future are just going to follow this general trajectory, right? You're going to use what you know from our oxidation rules and to figure out the oxidation numbers of something that you don't know. And it is using these oxidation numbers that we can track the movement or distribution of electrons in our oxidation reduction reactions. And so just keeping in mind before we end off, that you should always not keep in mind the overall charge when we're talking about our polyatomics, or with our neutral elements at 0. When we're talking about a polyatomic ion, the overall oxidation number, the sum of those oxidation numbers, is that of the ions. Don't mix up keep in mind your exceptions, right? As you know, those can trip you up if you don't keep those in mind. And well, that's pretty much it, actually. So thank you for watching the video. I hope you got some value out of this. If you did, please show your support by liking, subscribing, and leave in the comments what you guys would like to see next. And I'll see you in the next one.